G'day everyone, welcome to Lubrication Explained. Today I've got a really good discussion with Sanya Mathura of Strategic Reliability Solutions. She's an expert in lubricant degradation mechanisms, and I think that's a foundational concept that it's really important to understand for a couple of reasons. One, if you want to extend your oil life, you need a really good foundation in how that lubricant is failing, right? So that's one reason. The second reason is because lubricant degradation mechanisms also point towards a lot of equipment failure. So as we're doing things like RCFA, that's root cause failure analysis, we really need to have an understanding of the role that the lubricant plays in that equipment failure. Sanya, thank you so much for coming to talk to us today. I'm really excited about this one. Sanya is a bit of a thought leader within our industry, has done some really amazing work, and specifically what we're going to talk about today is the subject of her new book, which is Lubrication Degradation Mechanisms, the complete guide. So, there it is. Okay, excellent. So I'll put a link into it or something below so that people can find it as well. I'm really excited to talk about this because obviously lubrication degradation mechanisms are something that we've covered on this YouTube channel, but in bits and pieces, so it's by no means a complete guide. So it's good to have the expert here. And Sanya, do you want to maybe give us just a little bit of background on yourself and why did you write this book?
Oh boy, that's a question that I keep getting asked. Why? But the one of the main things is that I did my thesis for my MSc in engineering asset management. So while I was doing that, I was still working with Shell, and I'm like, what am I going to write my thesis on? Of course, it's going to be on oil. Like, why not? It has to be. That's what I'm doing, right? And I started working on it, and it was about investigating like the degradation mechanisms in an ammonia plant. And looking back on it now, I'm like, who chooses that topic for a thesis? Like, why, right? And what I realized when I was trying to get information for it is that a lot of the information wasn't readily available. Like, you had to know somebody who knew somebody who had something,
Yep.
and then you always have those confidentiality things coming into play. Can they share it, can they not share it? So what I realized from that, like after finishing the thesis and working with some of the real experts in the
Mm.
industry, they were able to share the stuff. And I'm like, this is such good information. And I ended up leaving the corporate world in 2017. And after a little bit of finishing out my thesis, then I started my business, Strategic Reliability Solutions Limited, where it's a culmination of different types of reliability services. So what I wanted to do is sort of have one place where people could come to and find different types of training in reliability, because like we all know, reliability is related to every single thing that we
Mm.
do, which is why I love it so much. And after getting into the business, I never thought about writing a book. Like, honestly, never thought about
Yeah.
it. But, Bob, he's like, you're going to write a book, And I'm like, no, Bob, not going to happen. Not going to happen today. Not going to happen this year. And when the pandemic struck, I was rolling out a lot of stuff throughout the Caribbean, constant travel, and then everything just went dead.
Mm.
It was just this very, very still time. And I'm like, well, now's a good time to write a book. Nobody's, bothering me for meetings. We're not having phone calls, random things. I had a lot of, I want to say, free time, but it wasn't so free because I started
Mm.
working on the book, and I just started to put all the information together. And again, reaching out to the experts in the industry to make sure that they validate and verify what I'm saying, to have this sort of guide where people people could go to and find all the different types of degradation mechanisms. And when I put it together, I was thinking, well, I hope at least one person buys it because at least one person might be interested in this. And it's been very strange that since like when it got released, I had people saying, "Oh my gosh, this sounds interesting. I want to get the book." And we had one of the guys in the UK, Wayne Hublal. He's like, he emailed me immediately, and he's like, I want 15 copies. Send them to the UK. I need this for every single one of my customers. They need this value in their life, and I'm like, okay, Wayne, are you sure?
Yeah.
You know,
Yeah, it's so interesting.
and
So I guess maybe for our audience, Sanya is
mhm,
effectively me, but like 3 years into the future, uh,
the female
and
version.
female, right? Obviously, um, but in the sense that a lot of what Sanya does is, um, as an independent lubrication consultant in based out of Trinidad, but
Mhm.
that's effectively what I'm trying to set up in Australia. And it's really
Okay.
interesting to see Sanya's success in doing that, but also the way that you have kind of shared your knowledge with a wider audience, which is effectively what I'm trying to do with this YouTube channel. So,
Mhm.
um, yeah, very very similar points of view, and that's why for the last few months I've been trying to get Sanya to come on.
Oh
We
yeah,
just needed to
I've been
find
trying.
an appropriate time, right? Just very very busy. Um, so maybe let's get into the actual degradation mechanisms themselves, right? Because
Oh yes.
I think in the book you sort of identify six major ones.
Yes.
So let's maybe just briefly go through what the six are, and then we can
Let's do
start to
that.
talk them
Because
about them a little bit more in detail about what are the ones which are maybe most plaguing the industry and some of the
mm,
solutions that are out there as well.
oh yeah, because we could probably sit here and talk about it for the entire day, but
Yeah,
let's
exactly.
not let's not get the audience like that, right? So basically, there are six different mechanisms, and the thing about it is that I say that there are six, and there are some people who classify them different because of the environment or the operating conditions. But your six major ones are oxidation. We always start with oxidation. Everybody thinks that oxidation is the only mechanism. So we're here to tell you it's not. It has friends, different friends. Oxidation, thermal degradation, then you have electrostatic spark discharge, microdieseling, additive depletion, and contamination.
Yep.
And there are a lot of people who think, contamination can't be a degradation mechanism, Why should it be even in that sphere? But when you think about it a little bit more, if you don't classify it as a mechanism and you're trying to figure out, the root cause of why this is happening to your turbine or a piece of equipment, and you don't consider contamination, then you can probably go down the wrong path. Because contamination could lead to oxidation, it could lead to microdieseling. And if you just stop at, okay, we're having microdieseling, that's at the end, and you haven't considered contamination, you're going to always get that issue, you're always going to get that problem. So that's why it's very important to have it as a separate mechanism.
Okay, so that sort of
But,
gets into the reasons why you might have written the book,
mm,
right? So
yes.
maybe if we can explain, the book is kind of written to be a helpful resource when you're trying to do an RCFA, right? A root cause failure analysis
It
investigation.
could be, yes.
And so if you don't
Mhm.
include contamination, then maybe you don't look for that as a root cause.
No, no, you don't. And one of the reasons that I wrote the book and is written in such a way that we start off with basics of lubrication because I'm always like, get the basics right
Mhm.
first. If you don't, things go haywire. So once we get the basics first, then we identify each of the different mechanisms. And each of the mechanisms, they produce different types of deposits.
Mhm.
So that's the important part of it, because the deposits you'll get from thermal degradation. With thermal degradation, you have the lubricant, being degraded, lots of heat, anything over 200 degrees Celsius, and it eventually goes down to coke and soot and tars. But if you're thinking about microdieseling, and some people think that microdieseling should just be under thermal degradation. It is a form of it, but when you really think about microdieseling, what happens in that is that you have entrained air. So you have air being trapped inside of the oil, and then it moves from a low pressure to a high pressure zone. And with that movement, you actually have that increase in temperature to over 1,000 degrees Celsius. Like I know Raf
Mm.
and I can't stand 37 degrees Celsius. It's just too much for us. We all have that on our regular day. But 1,000 degrees Celsius, and then you start seeing the bubble carbonize, and you start getting like soot. And what you'd notice on the inside is that you may start seeing cavitation marks because of those air bubbles exploding. And very interestingly for me, right? Interestingly enough, um, depending on the type of explosion of your bubble, you would have different types of degradation deposits being formed. So if it's like a high flash point, you can think about that like a bomb exploding. So you get incomplete combustion products. However, if you have a low flash point, then you get more of the coke and the soot and the tars because it's like complete combustion. So there are so many different things that you
Mm.
can determine, and that helps you to understand what's going on in the equipment. Because
Yep.
if you're just looking at your deposits and you're like, okay, well, I think it's oxidation, so you know what, I just have some free radicals forming somewhere and I need to sort that out, or throw some antioxidants in there and hope for the best.
Yep.
But you know, being able to identify exactly which mechanism it is can help you to determine what your root cause is and eventually lead you to no more problems, which is where
Yeah.
we all want to get at some point.
Yeah. So maybe if we just quickly dwell on microdieseling for a little bit. So people who've been watching this
Mhm.
channel, I did an explanation of microdieseling. Now it was a pretty short, not in-depth one, but it was that probably was about a month ago. So if you haven't seen it, what are you doing? Just
Look,
go back and
look
watch
it.
it.
Yeah.
um, but for those who are familiar with it, I guess most of the time people would associate microdieseling probably with hydraulic systems, right? So
Hmm.
often when the entrained air is going, when you said from a low
Yes.
pressure to a high pressure point, it's generally at the hydraulic pump,
Hmm.
right? So you've got an
Hmm.
excess of entrained air, and as it goes through the pump, it's obviously going from low to high pressure, and with that, I mean, it happens so fast, it's basically adiabatic compression, right? You get
Hmm.
a huge increase in the temperature in that air pocket, which is going to result in the types of phenomenon that you were talking about there, where it's either complete or incomplete combustion, depending on
Incomplete.
the
Hmm.
physical properties of the oil. So most people are associating it with hydraulic packs,
Oh,
but
okay.
where else have you seen microdieseling pop up in your line of work?
Microdistilling pops up all over. It's just that a lot of people don't recognize it, and they're
Yes.
like, the thing about it is that sometimes it happens in all of the smaller sumps. So the smaller the sump, they're like, okay, well, I'm just gonna change the oil. The end, no biggie. It doesn't cost as much. That's it. But I've seen it in some compressors, in some turbines, and we don't want to have that. We don't want to have any of that in any of those larger pieces of equipment because guess what happens? We have a shutdown, and then you have to call Raf and I in, and you may call us at 6 a.m. in the morning. That it doesn't work like that. You need to get that sorted out.
Yeah, and I think that that's an interesting one, which also highlights the need for you including contamination as one of your
Yes.
mechanisms, right? Because, I mean, without excessive air entrainment,
Uh huh.
microdieseling doesn't happen, and air entrainment realistically is a form of contamination.
It
It's
is.
just that your
It
contamination
is.
product is air; it's not like a physical particle or
Yeah.
something like that, right? So again, that sort of highlights that importance of in your RCFA. Okay, the fact that
Mhm.
you identified microdieseling is actually not the end point.
No,
Uh,
it's the
you have to
beginning.
show where the
It's
air is coming
just the
from.
beginning.
Yeah.
Yep. And so very, very key points to bring up. When I wrote the first book, I did I talked about the different mechanisms. I talked about the test. I talked about different physical ways you can try and not have these happening in your system. And I thought, okay, that's it, the end. That's the book. We're gonna leave it right there. And then I thought, oh my gosh, we just addressed only the physical issues of any of these degradation things. We never got into the actual root causes, going down to the human roots, going down to the systemic roots. And that is where a lot of the issues occur. And like in microdieseling, you know, if we're thinking about air getting into the system, what about if we had a technician that didn't align a part properly? So, and he didn't have the training. So let's go down to that root cause. If we don't get him that training, none of the parts that he's going to align is ever going to be properly done. So you're always going to have microdieseling, even though you change like the seals or whatever part, physical part you thought was affected or caused the air to be entrained. So that's in my second book. In my second book, we talk about getting into the root causes of lubrication degradation, and I've done stuff with each of the different six mechanisms and the like stuff associated with each of them. So I built out an RCA tree for all of them.
Okay,
So
very
Bob
cool.
helped me to get
Now,
that out of my head and in there.
yeah. Now, usually the sequel is usually not as good as the original, but in this case,
Oh.
the sequel is better. We're talking in general about the sort of the human factors, if you
Mhm.
like, um, and I think one thing that jumps out at me there is the need for kind of understanding and training, and just one thing that I guess I've seen in my experience at least is that often the people that are in contact with the lubricants on the most frequent basis are the people who receive the the least training of anyone on site.
Yes. Oh
I,
my
I don't know
gosh.
why it is, but for some reason, the lube tech, um, who literally, physically touches the equipment every day when he
And
does his lube
saves it.
rounds,
Hmm.
for whatever reason, that guy is always ignored, right? And undervalued and never receives any kind of instruction or formal training or anything like that. So, um, yeah, I mean, that's just a beef that I have with
I
the industry is like, why isn't that guy basically the most important person on site?
He
Um,
is. He
yeah,
is definitely, and it's a struggle that we see throughout the world. Because I see that on my side a lot as well, and I'm like, these are the guys and the girls, taking care of the equipment. They are the ones who I want to say give them that jump start and make sure that it actually works when it's supposed to.
yep,
And be just like you said, they are our frontline workers,
mm,
right? So they should be trained. They should be, knowledgeable about what happens. What does and it sounds weird, but what does the sound mean? If I
yeah,
see something happening like this, because they are the ones that they buy the equipment every day. They see it and they would notice the changes.
yep,
Whereas other people on the side may be like, that sounds a bit weird. Carrying on with my regular scheduled
mm,
program,
mm,
you know. But we need to get them trained, and getting them trained is actually helping the efficiency of your entire plant
yeah.
because
Because
they control it.
at the moment, it feels like they're relying a lot on uh, intuition, right? Because often,
Mm-hmm.
because the lube tech is in contact with a lot of this equipment on such a regular basis, they just know when something is different. They may
Yes,
not necessarily know
they
what's
do.
wrong, but they know that something has changed. And
Mm-hmm.
that's both in the equipment and in the lubricant too, right? Like sometimes, like you said,
They
on
sense it.
sound. So cavitation or
Mm-hmm.
microdieseling usually sounds
Mm-hmm.
like there's marbles in the machine,
Yeah.
right? And that's how usually one of the leading indicators. But also, um, with the lubricant, if they're pulling a lube sample, they often can tell by smell, right? That
Yes,
it
sometimes they
smells
can.
different to usual,
Yeah.
or
Mm-hmm.
sight, because the color has changed or something like that. So yeah, in the first video in this series, when we were talking
Uh-huh.
to Rich Wurzbach, he was actually talking about trying to translate the insights from a loop tech into something meaningful, right? Because he would say the loop
Mm-hmm.
tech recognized that there's a change in the color of the grease. He said, and
Yeah.
he doesn't know what that means necessarily or how the
Ah.
grease is
Mm-hmm.
degraded, but we should be using that information. Um, and so he kind of helped come up with some of the testing around grease
Ah.
colorimetry to
Mm-hmm.
identify
Yes.
grease degradation mechanisms,
Oh
um,
my gosh, yes.
based on color. So yeah,
Mm-hmm.
these techs seem to be this untapped resource, really. Um,
Yes, they
and so
are.
education, as an example, in the form of your book, it could be really
Mm-hmm.
helpful in helping them because again, they'll see the deposits, before anyone else does, and if they
Yes,
can
they do.
understand what that means and help categorize them, then I think that'd be really helpful for teams. But just maybe to talk about one of the other degradation mechanisms. I know you said
Uh-huh.
everyone always points to oxidation as being
They always
the
do,
cause of
always do.
everything. But let's talk about oxidation, right? Because um,
Mm-hmm.
maybe I think the one thing I'd like to understand from you a little bit better is um, oxidation is like the main culprit, if you like, that everyone
It
blames.
is.
But how is
Mm-hmm.
it different from the other degradation mechanisms that you identified?
So one of the first things would be that oxidation could occur at any point in time.
Yeah.
You know, a lot of people they define oxidation as you have addition of oxygen to your lubricant, but like the definition of oxidation has changed a bit. So I've seen the most recent definition as it's where a molecule loses an electron and becomes this free radical, and of course radicals loves friends, they love, love to have friends, love to have parties, so they always go around and they develop more free radicals, and then you have antioxidants sort of battling the free radicals to neutralize it until all of the antioxidants are done. They're completed, they're depleted, and then you have all of your deposits and whatnot being formed. So the thing about oxidation and why it gets such a, I want to say such a preference is because a lot of people know oxidation for producing these deposits with just by seeing increases in temperature, random little things, and they'll see the varnish forming. But what happens a lot of times is that people they're not familiar with the different types of mechanisms. So if they see like a very dark deposit, like being coke or soot, they would still think it's oxidation because they've been trained to think that the only type of degradation mechanism is oxidation.
Mhm.
Whereas if you get coke or soot or tar, it could be because you have microdieseling, or if you get, coke, you could be because you have thermal degradation. That's where you have, the oil being heated until you have no more air, you have dehydrogenation. So you start seeing those black deposits. You see similar black deposits for microdieseling, in addition to cavitation, electrostatic spark discharge. That's the electrifying one. That's the one that everybody, it happens so often, especially with hydraulics, because what you need to have is the buildup of static within your equipment and you have tight clearances.
Yep.
So that happens a lot with hydraulic equipment. And with ESD, what happens is that you actually see some of those sparks happening at the filter. So that's where a lot of that telltale sign for ESD. You see a filter membrane with also dark spots on it, all the burnt membrane. You definitely have ESD happening in there. If you have
Maybe
ESD,
just to quickly
yeah,
pick up on ESD because
uh-huh.
some people in the audience I think are never going to have heard of it, and for
That's
some
fine. That's
people,
why we're here.
yeah, and for some people it's like the bane of their existence. They know it
Mm-hmm,
exists, but
yes.
they have no idea how to solve it, right?
Mm-hmm.
So ESD seems to be a new phenomena. Not that it's
Oh, I
new and
see.
it has never existed,
Mm-hmm.
but it's something that people have become more aware of particularly in
It's now
hydraulics
being brought.
and even more so in turbine oils, right? Um, Now, so maybe if we can explain where how the buildup of charge occurs in a lube oil system, and then what are some of the maybe physical and chemical characteristics of the oil which can
Yes.
exacerbate that, right? Because one of the things, a little bit like the varnish problem, is that in turbine oils, ESD didn't seem to be as much of a problem back when we had Group 1 formulations. And as we
Oh
started
boy,
to,
we're going back into the formulations.
yeah, yeah. But as we started to move to sort of Group 2, Group 3, it became an increasing problem. And now it's something that
Yeah.
I think is pretty familiar to everyone in the turbo machinery world. So,
Uh-huh.
so if we could please maybe start with how does charge actually build up in a lube oil?
So think of it just as static that builds up when you walk through a carpeted room and you touch like a door handle. Like just by you walking and you're moving across the carpet, you build up charge. So the same thing sort of happens with oil. It's flowing through these very tight clearances. So it's gonna build up the charge on the inside there. And once it builds up that charge, it needs to be grounded. So any sharp objects within the actual system, like if you have a sharp point in a bearing, the charge could build up on that point and then discharge, and that's where you get the spark actually happening. So you start seeing that a lot. So of course, one of the telltale signs is you start seeing sparks within your equipment, but not all equipment we can see that. So a lot of times people they say that when they're walking by the turbines, they start to hear a crackling. So when you hear crackling, it sounds like static electricity. It is. It definitely is. So that's one of the things that you should look out for with ESD. And what happens there is that sometimes you get a release of different types of gases. So if you're testing for ESD, you're going to be doing like a FTIR test to figure out what sort of deposits you're having in there. And you're also going to want to do a dissolved gas analysis test. Because sometimes a lot of the times you get like ethylene and those sort of gases present when you have ESD happening because of the sparks going off, creating that not perfect environment, but creating that environment where you actually get these reactions starting to happen. So some things that you need to look at. And of course, your membranes on your filters, those are you're gonna start seeing burn patches, and not the best thing to be seeing in your filters.
Yeah, definitely. You know, and I've seen so many filters that have just been torn to shreds by
Dying.
ESD. And you'll occasionally see those spark markings, that sort of electrical
Yes.
discharge pattern on things like bearings and things as well, right? But uh, maybe if we could briefly touch on prevention too, right? As in,
Oh, yes.
is
Mm-hmm.
there a way, uh, you know, because
Yes.
the charge builds up in the lube oil system purely
Mm-hmm.
because of the motion of the
Yes.
lubricant through the system, right? So, like you said,
Mm-hmm.
it's like walking on carpet. It's
Yeah.
like that building of static electricity. And funnily
Mm-hmm.
enough, I mean, this is a problem that the fuel industry has been dealing with for, as long as there has been fuel, right? Because you've got to ensure the
Yes,
integrity of the fuel system and
always.
that they're not going to all of a sudden blow up. Um,
Mm-hmm.
Whereas in lube oils, it feels like it's a little bit newer to us. But
Mm-hmm.
um, yeah, so you can't in some ways necessarily prevent the buildup of charge, but how can you
Mm.
how can you distribute that charge in a way that's not harmful?
So there are a lot of things that you can do with ESD. There are lots of anti-static filters. So you can have those, and I think they're widely available. So it's just a matter of making sure that you get the right specification, for your piece of equipment. Of course, always relate it back to your equipment. Don't use what your neighbor is using, because just because they feel like using it. Relate it back to your equipment. There are anti-static filters. There are also there's some charge brushes, I think. I can't remember the exact name of it, but it's another grounding technique that can be used to like add on to your system to help, bring those charges to ground before they, wreak havoc on your oil. Another thing is actually making sure that your oil is over 100 picosiemens per meter. So that's one of the key things. It's something that's a little bit tricky to control. So that's why I'm like, stick to your anti-static charge filters, the ones that were easy to, quick, quick replace, it's just a plug and play unit, basically. And it could actually help you with your static that's being built up in your system. So easiest way to go there.
Yeah, and for anyone who's not familiar, so picosiemens is a sort of a measure of the conductivity of the oil, for want of a better word,
Mhm.
right? In roundabout
Yeah,
terms.
yeah. We will
Um,
work with that.
yeah, exactly. And when it's actually what dielectric potential, but let's just say it's
Yeah,
conductivity
that's
for
fine. That's fine.
simplicity's sake. Um, and I think where you're sort of getting to there is it's not easy to remedy that because
Hmm.
the the conductivity of the lubricant is basically determined by the formulation. And
Yes,
I
it
think,
is.
unfortunately, everyone's looking for a quick fix. That is to
Yeah.
say, hey, give me a chemical that I can just pour into my turbine oil
Uh,
that will
it never works like
increase that
that.
number, right? Like all I want is I want a number that's over 100. Give me something that puts it over 100.
Hmm.
And obviously, as we know, um, pour in top treat solutions, you've got to be very careful because the
Yes.
interactions with other
Hmm.
chemistries in the lubricant are something that you really need to look out for. Uh, it's not as simple as buying
No,
something
it's
off the
not as
shelf
making
and
tea.
pouring it in.
Mm-mm.
And I guess that maybe by way of explanation, the reason why conductivities have lowered is it is part of that move in the formulations from a
Yes.
group 1 to a 3. There's less
Hmm.
polarity in the systems, and that's helping contribute to that number going down. So anyway, but thanks for explaining ESD in a lot of detail because I think that's one which is pretty interesting for the audience. Um, Now, maybe a question to ask you. Um, Sorry, you're right. Oh, hang on, your voice is not coming
Yeah.
through. Oh, here we go. There we go. Got you
Your
back.
yes, you were kind of sticking for a bit there.
Yeah, yeah. You've gone. You just went fuzzy. Hang on a sec. Let me see. Oh no, it's gone good again. All right.
Okay.
Okay, we'll keep going. So I was going to basically go on to the question 4 at this point. Um,
That's fine.
uh, all right. So with your experience in the
Hmm.
industry, you obviously get to see a lot of this stuff. As an independent, I think one of the advantages is you get to sort of jump around to a bunch of different
Yes.
sites and
Yes.
see, what people are experiencing.
Hmm.
What do you see as being some of the biggest challenges? So maybe as a start, out of the 6 degradation mechanisms that you identified, which one is the one that you see most often?
Contamination,
Okay.
actually. Yeah, contamination, but a lot of people don't class it as that. They're like, no, I have oxidation. I'm like, no, you have contamination. Something is getting in there, and that's what's contaminating your oil. That's how you're getting those degradation mechanisms. So the most common is actually contamination, and a lot of people say no, that. But when you think about it, it's contamination all the way.
Yeah, and this and that's one of the things I guess in this industry is that there's just so many contamination points and
Yes.
people maybe don't realize it because they can't see it either, right? Like a lot of
Yep.
contamination
Hmm.
occurs in particle sizes that aren't visible to the eye.
Yeah.
Maybe it's air contamination, which you obviously can't
Yes.
see.
Oh my gosh.
So yeah, I mean a huge problem, and I think everyone in the industry is trying to highlight the size of the
Hmm.
problem, but it maybe doesn't
Yeah.
get the love and care that
Yes.
some of the other things
That
do.
it so richly deserves.
Yeah, Yeah, and so maybe to broaden out from that, because you did mention that the second book encompasses things like human factors and
Oh
and
yeah,
really um, going sort of from, let's
deeper.
say, the physical
Mm-hmm.
root causes back
Yeah,
to things like process
yeah.
and people. So
Mm-hmm.
if I were to take the totality, what do you see as some of the bigger challenges in our industry?
I think, like, for me, one of the biggest challenges that I see all of the time is that we have so many people leaving the industry, whether they're leaving for retirement
Mm,
or they're leaving to get a different type of job, and you just have that brain drain because nobody took the time to document or put things in place or say this is what this guy learned over the past few years dealing with the equipment, and the things that they learn, technicians, people working on the equipment on the ground, the things that they learn about that equipment may never be in the OEM manual. So the OEM may not even be around the equipment that long to see or to experience those different types of operating states and what happens to the equipment when it goes into that state. Not to mention that the operators push the equipment to some different levels because they're trying to achieve production. So you have some Frankenstein equipment as well all over the place, but it's just the loss of that knowledge that within the industry, like a lot of times, is lost and we can't get it back. We can't go and call the guy because he's out, on a boat somewhere, chilling out in the ocean, and he's not taking any calls. But I think one of the things that we should try capturing going forward is, how did we deal with this problem? How did we solve it? What are the steps that we took? Even though we took the wrong steps or the steps that we took, they weren't, very helpful, we can have that documented so that the next time it happens, somebody doesn't waste their time doing those same steps. So there's no such thing as, I need to have this done perfectly. I need to have the correct steps down there. No, just document the information because having the wrong steps helps people to prevent that loss of time in the future. So think about it from that perspective. And that's one of the things that a lot of people don't think about. They're just like, okay, well, yeah, I need to have that. It needs to be this, that, the next. So I've seen like training manuals or different work orders. They say, okay, tighten the pump, align the pump, align it to what specification. So, and for a new technician coming in, a new person, they're like, okay, well, it says to align it. Well, I'm just gonna do what I think is it's supposed to be done. Like you don't have a particular amount that it goes to, or the torque value. So things like that help us to, it helps us to improve our procedures. It helps us to capture the information that has been lost. Like you can have even on your procedures, when you hear this noise like marbles within your system, check for microdosing. That may be what's going on. So just the notes on different pieces of equipment, that's what I would love to see in the future. If somebody could capture that, and each site and each piece of equipment is so different, and the technicians working on it, they will know. So that's one of the biggest challenges that I've seen quite a lot, because sometimes we get into these things and they're like, yes, the guy before me talked about that, but I don't have his information, you know? So that's one of the
yeah,
biggest things.
that's a hard thing, right? I
Hmm.
think, like you said, it's so prevalent in the industry, but
Yeah.
it's interesting even thinking about it from a, let's say, a systems perspective.
Hmm.
You know, most companies, equipment wise, don't
Hmm.
accept sort of single point failures, right? They always
Yeah.
have redundancy and they have backup, but
Hmm.
they're willing to accept single point failures in their people, right? In the knowledge.
Hmm.
Like there's often one guy on
Yes.
site who's like the guy, he knows
The
everything,
guy to go to. Hmm.
and then either he gets sick or he leaves or he
Yes.
retires or he goes to another company because they're going to pay him more or whatever,
Hmm.
and you don't
and you
you
lose
don't get that
everything.
knowledge back, right?
Yeah.
So yeah, and even within our industry, right? Not just industry in general, but the
Mm-hmm.
lubricants industry as well. I mean, there is so much knowledge that's or
Yes.
actually that has left the industry in the last 12 months
Uh-huh.
because of covid resignations and
Yeah.
redundancies and things like that.
Mm-hmm.
um, yeah, it's just it's hard to watch,
It
especially
is.
when that knowledge transfer hasn't already occurred. So
Yeah.
thanks for highlighting that, because it's a huge one,
Mm-hmm.
right?
It definitely is.
Yeah. Hey, I think that's a great place to end. Sanya, thank you so much for coming to chat to us about lubrication degradation mechanisms. I'm definitely going to pin you down for a second interview
Yes, you
in future,
can.
so we can talk in even more detail, because I know we didn't even get halfway through uh,
Yeah.
covering
Mm-hmm.
lubricant degradation mechanisms in detail. So, thanks for your insight. Really appreciate it. And just as a reminder for anyone who's looking for the book, I'll put a link down in the description so that you can
Yes,
find
I will make sure he puts that link in the description. Don't
it.
worry.
All right. Thanks, Anya.
Thank you.